So in our previous video, we have learned about what's meant by the linear motion. So in this part, we are going to learn how to analyze that linear motion. Let's say there are two cars in a car race, participating in a car race. So actually they are going to move in a, let's say it's going to move in a direct path in a straight line. So actually we need to find some quantities to measure what's the linear motion are they having. So here the basic fundamental thing you need to know about the linear motion is we are going to study about distance and displacement. So what's meant by the distance is, let's say you are at home now. So actually what we do is, let's say there is a school, your school is near to your place. So we are planning to walk and go to school. So what you are planning is, let's say there are two routes. Let's say this is one route and another one is going a little bit like this. It's a long route. So what you are going to do is, actually you can choose this one path, the first path, otherwise you can choose this second path. Let's say on the first day you are deciding to go with this first path. So what's the distance, the path length? Let's say the road's total length is 500 meters. So the total length of the first road is 500 meter. So what's the distance for you have covered in your first day? Which means the distance is, it's going to be the total path length you have walked. So that's known as distance. So distance simply means the total path length, either you or vehicle. So in the next day, you are planning to go in a long route so you can meet your friend, let's say. So here you are going to go in this path, second path. So the path length, the road's total length is 1 kilometer. So what's the distance you are traveling along in the second day is, it's going to be 1 kilometers. Actually, we should know that distance is very simple, which means the total path length, the particle moved. So here in this example, we are the particle. So we are going to use this second road. So we knew that it's going to be 1 kilometer. We need to walk for 1 kilometer. So the distance would be, the total path length is going to be 1 kilometer. So in the next scenario, once you finish the school, we are very tired of studying these heavy subjects like physics. So what we are going to do is, we are going to come in the shortest path, which is 500 meter. Actually, we are having is 500 meter. So what's the total distance you have covered in that day? It's going to be, first of all, you have covered 1 kilometer, and after your school finished you are going to travel another 500 meter. So the total distance would be 1.5 kilometers. So it's very simple. I knew that you have actually grabbed it out. In the next videos we will discuss this little bit deeper, so don't worry about that. So this is the very simple explanation. So now we are going to move for displacement. So what's the simple difference between distance and displacement? Is we will learn about the scalar quantity as well as vector quantity. So distance is a scalar quantity, which means we are not considering about the direction. Actually, when you are considering about the 1 kilometer, it's not straight path. So actually in each point, the direction is going to be changing. Let's say when you are traveling along this path, you are going to move in this direction. After that, you are moving in this direction, and here we are moving on this direction. However, these all directions are changed, they all are different. However, we didn't consider about that direction, so that's known as scalar quantity. So distance is a scalar quantity. When you are considering about the displacement, it's a vector quantity, which means we are going to consider the direction as well. So what's mean by the displacement is the shortest distance between the 2 points. So let's say this is us. So this is our school. The shortest distance between these 2 points is known as displacement. So how to find this is, some might think the 500 meter is displacement, but actually it's not, because we knew that it's little bit, it has been a bend. So the shortest distance between the 2 points is going to be a straight line. It's going to be the shortest distance. So whether we are having a path like first or second, like having a road to connect this shortest distance, actually we don't have. So let's say this is 400 meter, but actually we are having the road up to 500 meter only. The minimum length of that road is 500 meter. So 400 meter is the distance between these 2 points, school and our place. So here the displacement is going to be 400 meter, which means always remember displacement is the shortest length between 2 points. And also we need to consider the direction. So actually in this part you can actually show that in this direction, from the beginning point we are starting from this, and once we reaching the school we are going to we are sitting in this place, let's say. So the displacement is 400 meter, the shortest distance between these 2 points. And the next is the direction is in from first point to second point, towards the second point. So this is known as displacement. But some might get doubt, although we are not having a road in that path, it's not a road, we are not having a 400-meter road. However, when we are considering about the displacement, we are only consider about the shortest distance between 2 points, whether we won't check whether we are having road on that or not. Actually, the student can't go through this 400 meter. Actually, we don't have road. That's the problem. He is going to use this path or this path, 1 kilometer. However, when we are considering about the displacement, we should consider what's the shortest distance between these 2 points. So here comes the question. Let's say he's getting back to the same position after his school finished. So they are asking, the question is asking, what's the total displacement for that day? Total displacement for that day. So always remember, you don't need to consider about these things. We are going to consider the starting point, the initial point of that particle, and after that ending point of that particle. So actually we knew that he has started from this point, from his home. And finally at that day, he has ended up in that same home. So what's the distance? Sorry, what's the shortest distance between these 2 points? These are the same points. He started from the home and again he came to the same place. So what's going to be the displacement is going to be 0. So if we consider about this initial point to school is going to be 400 meter in this direction. If we consider the total displacement for that day, we are going to come to the same position. So the displacement is going to be 0. So now we are going to have a question. So I hope this would we can further understand it very well. Let's say draw like this. So here is a point called A and B, and the length is, let's say this is 4 meter and this is 3 meter. We are planning to go from A to B. So what we are doing is, actually we need to go first in this path 4 meter straight, and after that we need to take right and go towards 3 meter ahead towards B. So here comes the question. You need to find what's the distance of the total traveling from A to B. So let's act like this, distance from A to B. The second part is, what's the displacement of from A to B? Displacement from A to B. This is your homework. You are going to stop this video. We are going to stop at this point. In the next video, we will discuss the answer of this question. So please try it in your own so you will get a clear understanding what's meant by the distance and displacement. Thank you for watching.